Unlimited deployment. We're going to use the service capability of AWS CloudFormation to deploy the Workspaces service, which is used to orchestrate AI Unlimited in your cloud environment. In order to start, you have to go to the public GitHub repo under the URL github.com Teradata AI Unlimited. You will see there a lot of templates. The key important free templates are in the section of deployments AWS templates. You can see here there are free templates. The AI Unlimited deployment with using ALB application load balancer, AI Unlimited deployment with network load balancer or without any load balancer. The key element here to choose is if you're going to use your original certifications, we recommend using ALB. If your network setup is forbidding you to connect to those systems that are deployed on demand, then sometimes you require network load balancer to be a front service which orchestrates the access using the private network. If you are not sure which setup to choose, we recommend to start without any load balancer, and this way you can generate your own certs and use them for secure connectivity. So in order to start, we're going to first clone the GitHub repo into the designated directory. I'm going to take the URL, go to the terminal window. In this example, I just created the small folder AI Unlimited demo. We're going to do git clone and provide the URL. This repository contains the templates that are used for deploying the service, as well as the additional examples and notebooks for you how to use and experiment using AI Unlimited. Now that we clone this repository, we can go into your cloud environment. In my case, it will be an AWS. Look for the CloudFormation section. Once this is done, we can create new stack. We're going to choose the new, and we're going to use the upload the template from our local drive. So we're going to choose the file, go to the directory, we just clone the repo, Unlimited, deployments, AWS, templates, Unlimited, and we're going to choose the without ALB. Now we click next. Now we have to provide the name of the stack. So we're going to say AI Unlimited demo. We're going to use the T3 micro. We don't require the larger instance, so you can go with the smallest one you can find in your region or availability zone. We're going to stick to the 20 gigabyte root volume size. We don't need bigger. In this case, we're going to generate AMI role, so we don't have to provide the new role. We don't need any permission boundaries. So you can see there's a lot of options here. Those options are representing your potential limitations into your cloud environment. So we recommend that you go and check with your cloud architect or cloud operation teams what are the elements you have to specify in your current environment. So in this case, we're going to select availability zone. I'm in the West region. We're not going to use the private. So private connectivity means that if you require and you want Workspaces service to communicate with the on-demand compute engines using the private network, you should choose the private. If you're okay using the public IP addresses, you don't have to choose this here. You can stick with the false statement. We're going to use the session manager. So in case of any problems, use of session manager allows me to connect to the Workspace service and check the logs and see what is happening. And if you ever face any problems, just use the session manager to connect, and we'll show you how to gather the logs and post them on the community forum. In this case, we're going to use my sandbox VPC. So we're going to connect to the existing VPC. Now the important element for this VPC and the subnet I'm going to use is, while we can have the subnets and VPC created, you have to remember that those subnets needs to be able to talk to the Docker Hub, because what we're going to do during the stack deployment, we're going to connect to the Docker Hub and pull the AI Unlimited workspace container. So make sure that your subnet is capable of talking to Docker Hub and pulling images from the Docker as part of the network configuration. In this case, we are not going to use any SSH key. If your organization required you to have a SSH key instead of session manager, you can create the keys in your AWS console and provide here the name. Just remember, this needs to be exact name of the key you created. In my case, I need to have access CIDRs. CIDRs for me are here. You can specify multiple of them depending on your configuration. So this is something why you need cloud operations teams to help you with the first deployment. If you require any prefix, you can specify here security group. In this case, I'm not going to use existing security group. I'm going to rely on the stack to create a security group, which will be useful for me later on when I'm going to do the engine configuration. Those are default ports. The port 3000 is used for the web portal that is used to configure the APIs as well as to configure the cloud deployment for the engine. The port 3282 is used for the gRPC API communication. So this is what allows the Jupyter to communicate as well as the client tool CLI to communicate with the workspace service. We're going to use the latest version of the container. We don't recommend choosing any other versions here, but in the future, if you want to restore a specific version of the workspace that you like it more than the latest one, or you don't want to rely on the latest changes and bug fixes, then you can specify a tag version from the Docker Hub. But we recommend the latest. We're going to use the persistent volume. So persistent volume allows me, in case your organization is not allowing you to run even the T3 micro instance forever, if the instance by any means going to be destroyed or something happens and it's going to crash, with the persistent volume, you can always come back and restore the metadata of the service. So you don't have to repeat the whole configuration process. You can just restore and attach existing volume that you already created. In my case, because this is the first deployment, we're going to use a new persistent volume, size is 20. If you are attaching to existing persistent volume, you have to provide the ID here. And then we're going to retain the volume in case something goes wrong. We click next. So now some organizations require you to use personal tagging. Sometimes it's a good practice to tag your resources in the cloud. In this case, I'm not going to provide any tag, but you could specify the tags to help you easily identify all the resources that were created during the stack creation. In this case, as I was saying, I'm going to rely on the stack to create the AMI role. So I don't have to specify any specific AMI role. If you need more descriptions about those parameters, you can always refer to the documentation page, which will help you understand all the AWS or Azure requirements. So if you look at the AWS requirements, we have detailed documentation which describe all the details, what is needed, and what permissions you have to have in order to deploy this in your own cloud environment. Because remember, this is the self-service on-demand deployment. We are not hosting this for you. This deployment is happening in your own cloud environment. Now we are going to allow to roll back resources if in case something goes wrong with the stack. Remember, sometimes stack creation may fail because some of the parameters you use are not giving you correct permissions. So always monitor the stack creations, but once it's done, everything will be up and running. And we will say delete all the new created resources in case something go wrong, or I want to delete and restart the stack creation Then we press next. Now we can verify all the parameters we use. Again, we didn't use any tagging. And now we are happy to start execution of the stack. Press submit. So what happens now, the stack is start creation. This process takes approximately 10-15 minutes. And you can see and monitor what is happening. Remember, this is not a real-time refresh. So anytime you want to see the progress, you have to refresh manually by using this button. Once the stack is created, you will see all the needed resources created here, as well as in the outputs, you will see what was created. So it's going to take 10-15 minutes because at this stage, what we are doing is we are pulling the T3 micro instance. We are installing Docker on the AWS Linux. We are pulling a Docker Hub container and starting this container for you so that you can have the service up and running. So now that our stack was completed, we can check in the events the item was created. Now we can go to the resources and see what was created. What is important is to remember the security group that will be useful for the future. If we go to the outputs, we can see the private IP, public IP of my workspace service. To verify that everything is working, I can copy the address, open new browser, HTTP, port 3000. So now I'm in the setup of the workspace. But before we continue, we will now create the OAuth application in GitHub. So in my case, I'm going to use GitHub as authentication mechanism to specify the users for collaborations and who can access the compute engine, as well as to allow me to orchestrate my data projects for experimentation. So we're going to GitHub, click on your user settings. Now we can go to developer settings, OAuth application, new OAuth application. We will call application AIU demo. The homepage URL will be the HTTP, the public IP address port 3000. And we're going to specify now also the callback URL. The callback URL for us will be port 3000. And then we go back to the documentation. As you can see, here you have all the details, what to put in the different values. I'm going to specify this here. Now my application is ready. I can register the application. Now there's a few important elements. You have to remember your client ID. So we're going to copy this because it will be needed in the future. The second thing is we have to generate now the access token, which is the secret. Now remember, this secret is only visible for some small period of time. So copy this because we will be needing this value in the later configuration. In case something happens and you forgot to copy this value, you can always generate the new secret, but you never can see the value after it will be masked. Now we are ready to continue configuration of the workspace service. As you can see now, the secret is no longer visible. So after updating application, I'm no longer able to see the secret. If you forgot to copy this, remember you can always regenerate the new secret. The client ID will be static for this OAuth application. Now we're going to need this IP address, so let me copy this. We're going to go to our service here, change the localhost into the public IP address. We're going to update this. Now we're going to use the Git provider, which is the GitHub. You can always choose GitLab if you want. It's up to you, depending on which Git provider you are using in your organization. Because it's my first deployment, I'm going to set up the log level to debug. And again, we're going to show you how to grab those logs in case something goes wrong. If not, this is useful in case of any problems. then you can always post those logs back to Teradata using the community forum, and somebody will respond to you and help you orchestrate and fix the problem. We're going to use the public network. Again, that is to how the workspace is going to communicate with the on-demand engines. In my case, I'm going to use public, but you can always use the private network. And this way, the other people in your organization will not be able to access the engine, only the workspace, and you will be capable of doing this. In this case, because I didn't have ALB, I'm going to generate my own certificates. And as you can see, the TLS support is enabled, and I have my certs generated as a self-signed certificates. I'm going to update this information. Now we're going to specify a small amount of details for my AWS deployments. So I'm going to use, in my case, West 2 region. My subnet is the one I was using for the stack. So this is the same subnet. I don't need to specify the role. Again, if you require any resource tags, you can specify them here. In my case, I don't have to, but what I need is provide the CIDRs. And also because I was deploying this using the stack, what I need to copy here is the security group. So I'm going to go to the stack again, copy the security group. Can go back here and provide the security group. So this will allow me to be in the same security group when I'm going to be doing on-demand deployments. So this is the bare minimum of information you have to provide. Again, in my case, I have to specify the CIDRs, but security group is important because otherwise the workspace will not be able to communicate. Can now update, and now we can check the Git integration. So because we are using the public GitHub website, so we don't have to specify any URL. If you're using enterprise GitHub and you have a custom DNS name for your Git instance, you have to provide this URL here. So what we're going to do is provide the client ID and the secret we get from the OAuth application. Let me copy the client ID and the secret. Now there's two other parameters which are crucial potentially for you. So there's authorization organization and repository organization. Authorization organization is allowing you to limit who can access the workspace based on the sub-organization you created. In our case, we are not using organization, and therefore we allow only the one user to be connected for security reasons. But if you want to have multiple users orchestrating and working on the project, we recommend creating authorization, which you can do even in your public GitHub under your personal account. You just need to make sure that you authorize this organization and add collaborators there. The repository organization is where you can specify under which organization you want those project repositories to be created. Now, in some cases, you can, if you don't specify this, those repositories will be created under your user accounts. It doesn't stop you from collaborating. You can still invite other collaborators to be part of your projects, but for sometimes much cleaner view of the repositories, it is recommended to use the repository organization as a placeholder for all the projects and repositories to be created. In my case, I'm going to allow repositories to be created under my personal account, as well as I don't need to enable other people to join my organization. Now we provide all the details. We can authenticate ourselves against the GitHub. So I'm going to authorize, and now I'm authorized. So I can go now into the top of the page because I'm the owner who created the workspace service. In order for me to see the API key, I have to go to the profile page. As you can see now, I have my API key. Now, key element is because we enable certifications, because we're not using ALB, and I just generated those certs, I have to restart the service so that the service is now going to be aware that there is a TLS to be used. So I'm going to press restart. Now my service is restarted. So you can see API key didn't change. I can copy this because it will be useful for me to use this API key in the future. So with those steps, you just finished configuring the workspace service. The next step will be to run the Docker locally to run the Jupyter. There's a few options. You can use the CloudFormation template. We also provide the public GitHub repo to see and deploy the Jupyter container for each user in the cloud. Or if you're like me, you prefer to use the local Jupyter instance. So this way I don't have to go to the cloud to connect. I can basically live with the latency on my own machine. I can use the local container. So we'll now go and open the Jupyter container on my own instance. So to do this, I have, let me create the folder. So this folder will be used to map the Jupyter home drive into this folder. We can now run the Docker run. What we have to change is only provide a new directory, which we just created. So we're going to use demo dd Jupyter. And as you can see, it will be mapped to the Jupyter home directory inside the container. In the future, we recommend using the latest as a tag. Right now, I'm going to use the specific version of the Jupyter. Let me start my Jupyter Docker service. So I had to start my local Docker. So let me restart the command. If this is the first time you're pulling the image from the Docker Hub, it will take a bit longer, but I already have this image created locally, so I can now just click on the website and connect to my Jupyter instance. To click on AI Unlimited, so I can now create a configuration which allows my Jupyter to talk to the workspace service. I'm going to use the Get Started notebook, which you can find in the GitHub Teradata AI Unlimited. If you look at examples folder, there's Get Started, and you can see Get Started notebook. You can already copy this notebook to your Jupyter folder, or you can also just copy paste the commands. So we're going to create a configuration. In our case, we're going to use HTTPS because we are using the TLS. The IP address we get from the stack. Remember, this time you're using the port 3282, and the API key is the one we got from our workspace. So we can copy this here, specify the API key. In our case, as you remember, we enable TLS, so we're going to use with TLS option. Now the Jupyter know how to talk to the workspace. What we can do is do project list. We don't have any projects. So what we can do now is create the project, create. If you don't know the commands, you can always use the help command. So you can use help project create. That will display to you the parameters which are required and optional. You can always go back to the get started and see here you have examples of the commands that are going to be used. So let's do project create. We'll name projects AU demo 1. Environment is AWS. Now the project is created. We can list the project and see. As you can see, what happened is we not only created the metadata for the project in the service, we also created a repository under my GitHub user. So if I click here, you can see we created the empty repository. This repository will be useful because we're going to store here the schema. So any foreign tables, any views, any objects you created during your experimentations on the provision engine, those objects at every suspend will be stored here with the specific GitHub reference. So you can always go back. So every time you redeploy the engine, if the schema was created before, we will restore the schema automatically. So you have this feeling of continuation here. Now the next step is we can deploy the engine. So let's test this. I'm going to go back to the example and we can deploy the engine. Going to do project engine deploy. The name of the project is the one we just created. Now we're going to use a medium-sized system, and by default it will be one node. If you want to provide more than one node, you can specify this by using comma node equal to whatever number you want. If you just want to do this test as a first experimentation, we can start with the one node. You can also choose bigger one or smaller one. In my case, I'm going to go with one node, and the size of the system will be medium. Now what is happening is the workspace engine is orchestrating provisioning of Teradata AI Unlimited engine. The compute engine is created under your account in your cloud, and it's going to take approximately 8 minutes. The good part is this time is not dependent on the size of the system or how many nodes you wanted to deploy. It takes approximately always the same time to deploy small or large systems. You will see progress happening here, but as I said, it's taking approximately 8 minutes to see the full deployment. So our deployment failed, which is good because we can show you how to debug and find the root cause, what happened. There's probably some restrictions on the network, but let's double check this. So in order to do this, we're going to go to our AWS console, choose our workspace instance. This is our AI Unlimited. We can connect. As you remember, we set up the session manager, which allows us to SSH to the node from the AWS console. We can do SH. We need to find the container so we can get the logs. Docker container list. We can copy container ID. Now we can press Docker logs ID of the container. As you can see, we get the deployment timeout. The good part is if any error happened during the deployment, we automatically suspend the infrastructure, so I'm not going to be charged for the not used infrastructure or wrongly deployed infrastructure. But what we can see here is that when we started provisioning, the workspace was not able to communicate using the public IP. That's probably because our subnet doesn't allow us to do this. So what we have to do now is go back to the workspace configuration setup page and change the default setting to use the private network. So this way we'll be able to communicate using the private IP subnet. Press update. Now we can go back to the notebook and start redeployment of the engine. So as you can see, the engine was deployed. It took 7 minutes 39 seconds. Now the engine is connected and deployed on your AWS account. It automatically derives the user from the GitHub as well as generate the random password. If you look at the connection manager and refresh connections, you will see that now you have 2 connections automatically created To connect to the engine, you can use the command %connect and the name of the project, which in our case is AIU Demo 1. The connection is established. We can now start writing our queries, run our ClearScape functions, do any data projects we want to do. For how to use the SQL statement or Python code, look at other videos. Once you are done with the experiment, you want to deprovision the infrastructure. To do this, you can do it by posting command project engine suspend, name of the project, and that will allow us to destroy the infrastructure until next time I want to provision the engine for usage. Suspend typically take up to 2 minutes. During this process, we are removing the infrastructure from your account for the compute engine, as well as we are doing the backup of any object definitions you created using your SQL statements. Once this is completed, the connections will automatically be removed because the next deploy engine will have different connection details. So those details will not be valid when you deprovision the cluster. So in this session, you are able to create from scratch the deployment of the workspace service to run AI Unlimited, as well as by accident, we show you how to debug and submit any changes to your configuration, which forbids you from deploying the infrastructure. If you ever need any help from Teradata, remember you can always go to the community forum, so support.teradata.com. Here you have the forum related to AI Unlimited, and you can submit your question, and there will be always somebody to answer and help you figure out what is wrong, what can be changed. Do you have any restrictions which needs to be overcome for deploying the workspace? Thank you.